Hi guys, I'm going to go ahead and do an example of one of each type pretty much on the 9.1, 9.2 worksheet. I'm going to start with number 1C. So on number 1C, we have 9 to the 3 halves. So because this is a rational exponent, we can rewrite this as 9 to the 1 half to the third. Then because it's 9 to the 1 half, which is the same thing as the square root of 9 to the third power still, because 9 to the 1 half and the square root of 9 are the same. The square root of 9 is 3, which is still raised to the third power, and then 3 to the third is 27, and then that would be our final answer. So evaluating 9 to the 3 halves is 27. Going ahead and looking at 2b, we want to write this without a radical sign. So the radical here is a cubed root. A cubed root is the same thing as a power of 1/3. So everything under the radical is going to get a power of 1/3. So this is going to be 3 to the 1/3 times t to the third to the 1/3. 3 to the 1/3 I cannot simplify, so that's going to stay as 3 to the 1/3 times t to the third to the 1/3. When we have an exponent and we're raising that to an exponent, we multiply, and 3 times 1/3 is just 1. So it would just be 3 to the 1/3 times t, and then that would be our final answer. Looking at number 3, they want us to rewrite this with a radical sign. Looking at 3c, we have x to the 1/5 times w to the 3/5. Now to write this with a radical sign, we need to know what our root number is going to be. Since these both have a denominator of 5, so we have a common denominator, we're going to use a fifth root. So I have x to the 1/5, but I'm going to break up the 3/5 exponent on the w as w to the third to the 1/5. I can break that apart because 3 times 1/5 is still 3/5. But now both x and w to the third are to the 1/5. So I can use a fifth root of x times w to the third. And then that would be our final answer. Looking at number 4, they want us to solve the following equations for a given variable. I'm going to do 4a, and we're solving that for r. So I have w equals 4/3 pi times p times r to the third. The first thing I want to do is get rid of the 4/3. So I'm going to multiply both sides by the reciprocal 3/4. So I'm going to multiply by 3/4 on both sides. So I end up with 3/4 w equals pi times p times r to the third. Now since I'm trying to solve for r, I'm going to isolate that r to the third by dividing by pi times p on both sides. That will leave me with 3/4 w over pi times p equals r to the third. To get rid of that third power, I take the cubed root on both sides, and then r will equal the cubed root of 3/4 w over pi times p. And then that is our final answer. Okay, so the rest of this is just simplifying the following expressions completely with non-negative exponents. So all of the exponents need to be positive, and we're just going to use our properties of exponents. So I'm going to start with number 5. So I'm just multiplying here. When you multiply things with exponents, you add the exponents together. So I do have some numbers though. I have 4 and 3, and 4 times 3 is 12. And then I would have a to the third times a to the -4th. So I would add 3 plus -4, and I would get a to the -1. Then I have b squared times b to the third, and I would add those exponents. So that would be times b, 2 plus 3 is 5. So I end up with 12 times a to the negative 1 times b to the fifth. However, I have a negative exponent, so we have to take the reciprocal of that. So this would become 12 times 1 over a times b to the fifth, which simplifies to be 12b to the fifth over a. And then that would be our final answer for number 5. So I'm going to do number 12 now, and we are dividing m to the fourth by 2m to the fourth. When you divide, we're going to end up subtracting our exponents. So in this particular case, you always do the top minus the bottom. So I would do 4 minus 4. So this will become m to the 0, because 4 minus 4 is 0, over 2. And then I'd have m to the 0, which is 1, because anything to the 0 power is just 1, over 2. So my final answer is just 1/2. The last one we're going to do is number 16. So number 16 is 2h to the third, m to the negative third, k to the fourth, over 3mk, all raised to the negative 2. When we have a negative exponent, we take the reciprocal. So what I would actually do here is I would take a reciprocal of the entire fraction, and that will make that outside fraction positive. Now you don't actually have to do this. You could apply that negative 2 to everything on the inside, but I find that we deal with less negative exponents in the long run if we just go ahead and take the reciprocal of the entire fraction to begin with. So if I take the reciprocal, that means I have 3mk on the top now. In the denominator, it would be 2h to the third, m to the negative third, k to the fourth, and then that whole thing is now raised to a positive 2 because I took the reciprocal, so the exponent changes sign. So now it went from a negative to a positive. Now I can apply that positive 2 to everything inside. So I would have 3 squared, m squared, k squared, over 2 squared. Now I have a power to a power, so I'm going to multiply. So 3 times 2 is 6, so I'd have h to the 6th. Negative 3 times 2 would be m to the negative 6. And then k to the 4th, so 4 times 2, it would be k to the 8th. So again, I applied this exponent of 2 on the outside to everything on the inside. Then I can start to simplify. So on the top, 3 squared is 9. And then I have m squared on the top and m to the negative 6 in the denominator. So since I'm dividing, I subtract my exponents. And 2 minus a negative 6 is equal to a positive 8. So this would be m to the 8th. And then I have k squared over k to the 8th. So again, I'm dividing, so I'm going to subtract. So 2 minus 8 is negative 6. So I would have k to the negative 6 over 2 squared is 4, and I have h to the 6. So I still have a negative exponent, and I don't want any negative exponents. So we have one final step. I would have to take the reciprocal of the k to the negative 6 because of the negative exponent. So what that really does is it kind of just moves it to the denominator. So I end up with 9m to the 8th on the top over 4h to the 6th, k to the 6th in the denominator, and then that would be our final answer. Okay, so those are all the problems that I'm giving examples of in the video. If you have more questions as you are working on this, please feel free to email me, or you can ask questions when we have our Google Meet. Thanks, guys.